This is Geometry, Unit 1, Lesson 3. We are going to look at constructing perpendicular bisectors in this lesson. So perpendicular, remember it means that we have a 90-degree angle. Bisector, bisect, two section. That means that we're cutting them into two equal sections. We cut it right in the middle. One of the reasons that perpendicular bisectors, that these constructions are helpful that we're about to do, back in I think it was lesson 1, we looked at some illegal construction moves. Remember, the illegal piece was when we had to estimate where the midpoint of a segment was located. We do not ever want to have to use estimations. So if I can figure out where the perpendicular bisector should go, it's going to tell me where the halfway mark is. So we're going to start out just kind of exploring, right? We've got 2 points labeled A and B, and then we have a line segment CD here. The instructions ask us to mark 5 points that are a distance CD away from point A. So I need to copy this length of CD, and I need to find some points that are that same distance away from point A, and I'm going to end up marking those points here on my diagram. All right, so to copy the length of CD, I'm just going to use the pen tool here. And let's see, I might have to minimize this part. All right, I am just going to try to draw a segment on top of CD. So now I have copied the length of CD. I'm going to come back to my tools and I'm going to click on Select Objects. I'm going to pick up that segment and I'm going to bring it over so the end point of the segment is on point A. All right, so when I do that, where the other end point is, I'm just going to mark that point. Let's see, I'm going to mark it with, I don't know, let's do green. Okay, so at this other end point, I'm going to mark a point there. Okay, now I can come back and I can click on my Select Objects tool. And I think it's going to let me rotate this point, or this line around a little bit, so I can line it back up with A. Well, that's still the same distance. It's still the same length that CD was, right? So then I can use the pen and, oops, and mark a point. Okay, so I'm just going to keep continuing that pattern. All right, so here are the 5 points that I picked out. You may have picked out 5 different points. If I start looking at maybe 10 or 15 or 20 or 100 points, when I start adding in those extra points, hopefully you're seeing that, kind of visualizing that when I add in other points that are that same distance away, I'm really just filling in other points that are all along the edge of the same circle, right? And I could come over here this way, right, and do the same thing, and then I would see the entire 360 degrees of the circle. So when it's asking us how could you describe all of the points that are a distance of CD away from point A, well, they're going to create a circle. We're going to do the same process. We're going to mark 5 points that are a distance of CD, but this time away from point B. So I already have the length of CD kind of measured out here using my different tools. I'm just going to do just like we did with A, and I'm going to mark 5 points that are the same distance away from point B. Okay, so here are my 5 points that are all the same distance of CD, but this time it's away from point B. So again, if we start visualizing adding in all of the other possible points that we could have chosen, hopefully we're seeing that this is giving us a circle, and this circle is just centered around B. But it's going to be the exact same size as the circle that was centered around A, right? Because we used the same length for the radius for both circles. So when it says, how could you describe all points that are a distance CD away from point B? Well, it is also a circle. Okay, so then in a different color, mark all of the points that are a distance CD away from both A and B at the same time. So if I am using a different color, let's see, let's do orange. All right, the points that are the same distance away from A and B at the same time. Well, when I start looking at where my two circles would be intersecting each other, this point is the distance of CD away from A, and it's also that same distance away from B, right? Because it's going to be like a radius for both of those circles. The same thing happens where your two circles would intersect each other down here at the bottom. The exact same reason, right? From A to this point and from B to this point are both the same length as CD. They're both a radius for the circles. So right here, where we're going to type, we're just going to say that both of these points of intersection are a distance of CD away from both A and B at the same time. All right, so on the next task, it says your teacher will mark points A and B on the floor. This was just a little activity that we did in class. So what I asked people to do was stand where they were the exact same distance away from the smart board at the front of the room as they were away from the whiteboard on the back wall. And what ended up happening was everybody ended up standing kind of in a line. So I'm just going to draw a diagram of what happened right here. And then I'm going to come back to this one and answer, type in what it looked like. Okay. When I am labeling these, so I'm just going to label them. Here's the smart board. I'm going to call that point A. And then in the back of the classroom was the whiteboard. I'm going to label that B, right? It's on the back wall here. So everybody in the classroom got up out of their desks. And we had some people who tried to stand in the exact midpoint right here, right? But only one person can stand exactly where the midpoint goes. So somebody had to stand next to them. Well, when they stood next to them, right, that distance from A and B is still the same. It's still equal on both sides. And so then other people started lining up behind them. And pretty soon we had what was pretty close to a single file line in the middle of the classroom. So when we're looking at what happened here, right, we can represent all the people standing here with a line because they were standing in a single file line. And any person that I picked out, if we measured their distance from A and B, from the front smartboard to the back whiteboard, then those distances were the same. So this line right here is exactly in the middle of those 2 points. All right, I need to come back up here. Okay, so I'm going to say that our class stood in a line in the middle of the classroom. Okay, let's see. We actually skipped over this part in class, so you can just skip these two. What would happen if we didn't confine ourselves to the floor? That's just asking us to think about a three-dimensional space. And then what would the set of points that were equidistant from two different points look like? All right, I would like you to come on to this next task here. This is where we're actually going to construct a perpendicular bisector. So we're going to use the idea of our segment PQ with perpendicular bisectors. We're going to use the idea of having congruent circles to figure out maybe where a midway point would be. So I'm going to use, let's do circle with the center through a point. And I'm going to draw a circle that has a center at P and a radius of length PQ. Then I'm going to draw, I think that's going to be too large. So let me see if I can zoom out a little bit. There we go. We should be able to see just fine now. All right, so I'm going to make another circle. This one's centered at Q, and it's going to have a radius of PQ. So my two circles are congruent to each other. When I've constructed my two circles, those intersection points where the two circles meet, those are the points that we're going to connect that are going to give us the perpendicular bisector. And so we can see that we have our 90-degree angle, And the place where that perpendicular bisector crosses segment PQ, this point here, is going to be the midpoint. From P to that point is equal to the length from Q to that point. Okay, so you're just going to try a little bit on this last task, see if you can come up with another method to find the perpendicular bisector.